Hey everybody, thanks for joining us on this quick little PD Bite. It's a Math Tech Minute day, and today we're looking at making math stick, moving beyond the flashcards and thinking about concrete to representational to abstract instructional models. So I'm going to jump right in. This is really going to be just kind of a quick overview, and likely a lot of this is not going to be new. You probably have heard some of these things. In fact, you have a lot of resources to do this already, so it's likely going to be just kind of a good review of some strategies that you can think about when designing instruction in K-5 math. So I'm going to flip my screen here. All right. Up here is a shortened URL. So if you want a copy of the slide deck, you can go to this URL down here and get yourself a copy of the slide deck. You can also use the live question and answer feature by using this other URL at the very, very top of the slide deck. So there are two different URLs. Again, the one on the bottom here is for you to grab your own copy of this slide deck. And I've made the slide deck really interactive. So there's going to be a lot of links to articles and readings and resources and things. So I would grab the deck for yourself to save it and use later. But if you want to ask a live question, you can do that using this Ask a Question URL. So sorry, two different URLs. Google made a change to the way the Q&A feature works in these Hangouts. So this is the new model. But let's jump in. So first of all, I wanted to just start with talking about what does rigor really mean. So it's kind of a word that's getting tossed around a lot now in mathematics, especially since the onset of the Common Core standards. And I liked this model in describing what rigor actually means in mathematics as defined by NCTM, the National Council of Teachers of Mathematics. So, and I linked down here to the NCTM webpage with some more information. But the way that NCTM defines rigor in mathematics is that it really is a balance of instruction in conceptual mathematics, procedural mathematics, and then application of the mathematics. So what is rigor not? It doesn't mean like making the work harder for kids. And it's not about making the work difficult. It's about having a balance between these three things in your math instruction. So if you want to read more, you can click on that link down there to read a bit more. And so just a little bit of background, likely review for anyone that's watching this, but what does conceptual and what does procedural really mean? So conceptual understandings, right? That's student constructed understanding, the why behind procedures, but more than that, also the connections between mathematical ideas, being able to represent and reason math concepts. And also, this was kind of interesting, something I learned recently, that it also is about being able to compare and contrast related ideas. So can students compare two different math concepts? Do they know how those two things are related? Do they know how they're different from each other? And all that falls under conceptual understanding. And then procedural fluencies, and there's a lot of debate around what fluency really means. But again, I pulled this from NCTM, which is a really good source for not only math research, but lesson plans and ideas and things too. So again, a really great site to check out. You might consider joining as a member if you're passionate about math instruction. But procedural fluency, again, as defined by NCTM, is yes, it's the ability to apply procedures accurately, efficiently, and flexibly. I think that kind of has, I think that is the definition that we're all pretty used to, that idea that students can, solve a math equation or a math algorithm efficiently, right? We're talking about efficiency in choosing which algorithm we're going to use to solve a problem, right? But there's actually more to it. So understanding how numbers are composed and decomposed. So what kind of number sense do students have? Can students transfer procedures to different problems and contexts, right? So if we're constantly teaching them the addition algorithm in one context, are they able to transfer that understanding? If they're not, then maybe we need to work on that aspect of procedural fluency. Can students build on or modify procedures from others? This is super interesting, right? But it's that idea, for example, of in the math progressions documents, it talks about moving from addition into multiplication. So in second grade, students are working a lot more on addition and extending their addition understanding. And then they also are supposed to start talking about repeated addition and looking for patterns in repeated addition and relating that to arrays and equal groupings and things. And that's building up towards their multiplication work that will begin really in third grade heavily. So that kind of idea. And then also, can students choose the appropriate procedure? So do they know what procedure to choose when they are solving problems? So just a little bit of background on the difference between conceptual and procedural fluency, because that's going to lead us into, one of my favorite ideas. Fluency does not equal speed. So I think, and this is something that I think is really challenging to kind of rethink, just because we're so used to the idea of time tests and that being the ultimate test of a student's fluency in math. But really, a lot of the research out there around math instruction talks about fluency and procedural fluency. It's not the same thing as being fast at math. You don't have to be fast at math to be good at math. So I linked to an article with a lot more information about that down here, Fluency Without Fear. It's by Jo Boaler. So if you're familiar with her work, this is one of her articles about fluency instruction, and she gives some really great resources for teaching fluency in different ways. There's also her book, Mathematical Mindsets, is also really great about giving more information about procedural fluency and how to teach that. But just kind of want to throw this out here because that's going to lead us into the next bit, which is talking about CRA. So CRA instructional sequences are the idea that we are starting with concrete representations in math and moving into the representational and abstract from there, or thinking about them all together and how they relate. So I linked down here to another article. So again, really interactive slide deck, but down here is a nice quick article from KQED about what neuroscience can tell us about making fractions stick, specifically in this article, but really it relates a lot to math instruction in general, and the idea that there are studies around brain science and how we make learning stick, and a lot of that has to do with teaching a topic in context and helping the brain make connections. And so opening math instruction with something physical, something tangible, something that we can move and manipulate and work with is helping us build these connections in our brain that are going to lead to longer lasting understandings in mathematics. So again, likely this is something that we're all kind of familiar with, and maybe we just didn't know that it was referred to as concrete to representational to abstract. Something that I did learn recently, though, is that the idea that no matter kind of how you present this, if you present all three of these things in one lesson together, or if you present them one at a time, it is really important to take the time to do that concrete work first. You might do the concrete and then jump into the abstract. When you do that, it's really powerful to have students try and develop that algorithm, or have students pull out that math rule of their own accord first, and perhaps with the teacher using guiding questions to get them there. Or you might use a concrete representation and then do a representational and then do an abstract. You can do them one at a time, or you can do a concrete representational together and then go to the abstract. But the one thing that never kind of gets lost is that concrete understanding. So, and then I thought this was really kind of a nice visual to think about concrete and representational and abstract instruction and finding kind of that sweet spot, right? So finding the balance among the three. But again, just thinking about how important those concrete math explorations are in your instruction. And if you want to read more, there's a link on the bottom of the slide as well. So here was one example that was posed to me recently and I thought was really helpful. But in this example, the teacher put up all three representations together. So here's the concrete representation. So these are our base 10 blocks, right? So it would be nice if we had these on the desks and we were making this model with our base 10 blocks. Here's the representational and area model next to the abstract model, the algorithm, right? And so all three of these were projected together, and the question was, what connections can you make by seeing all three of these together? And so we had a really nice discussion around the connections that are built by being able to see all three of these things together. For example, something that I noticed that I hadn't really thought about before, I use base 10 blocks a lot. I have the kids use them in math, but arranging them this way to look like the area model that I was teaching them to use was really powerful. And I had never done that before, and I hadn't thought about it before. This is also really useful in preparing kids for algebra work in middle school, because when they get into working with polynomials, the area models get used in a similar manner with algebra tiles. So this all is kind of building up to work that they're going to be doing in middle school algebra as well. So kind of a powerful thing to see them all there together. So this is one way that you could bring CRA into your instruction and do all the things at the same time and see what students, what connections students can make of having all these things together. And this, you wouldn't have to necessarily have them solve this, right? You could give it to them solved like this too, and just say, what do you notice about these things? What do you see here, right? And then use this as a launching point into your lesson and get out the base 10 blocks and start doing the work yourself. So something really important, don't hide the manipulatives. Do students have access to these things, right? It's hard when, oops, backing up. It's hard for kids to use the manipulatives if they're not out there for them. And I know that management can sometimes be a nightmare. It's completely a valid concern, but it is really helpful for them to have those things. And it also, if you do end up reading more about this, researchers do say it is hard for students that have already gotten used to doing the algorithm to go backwards, right, and do that hands-on work first. And that's a lot of what we're still doing with the shift into Common Core, is we're still trying to take some kids backwards, and it can be a struggle, but in the long term, it is so much more useful for their math understanding, and especially in getting them through advanced mathematics. So it is important to have those things out, make kids use them, have them available for kids that want to use them more often. And if they see them sitting in front of them, they're more likely to take them out and use them than if they're hidden away in a cupboard, and then they don't tend to ask you. So something to think about. Okay, so I just want to show you a couple of examples of kind of designing lessons around this idea of the CRA progression. And I wanted to start with resources we already have. You don't have to recreate the wheel. We do already have lessons that we can work with and start with. So I pulled from Eureka Math, since that's what we are currently using, and I dove in and did some annotating. I linked to the entire annotated documents here on the slide if you want those, but I just wanted to look at, all right, what would this progression look like in a couple of lessons. So this is a second grade example. This is sums and differences within 100. Here are the specific standards here. But one of the, probably the, I would say the essential standard of this group right here is this fluently adding and subtracting within 100 using strategies based on place value, properties of operations, and or the relationship between addition and subtraction. So thinking about that, right, with the shift in Common Core is no longer that we just say students need to be adding and subtracting within 100. It's specifically calling out that students must be using strategies that are based on some of these things. And so again, another reason why bringing in those hands-on things are going to be so valuable. The nice thing is in the Eureka program that at the beginning of each lesson, it will tell you what hands-on manipulatives you need. As you're customizing lessons though, something you want to think about is usually the layout of a topic is starting with that hands-on and then slowly building into that abstract work. So as you're determining which lessons you're going to use and which ones you're going to alter and which ones you don't necessarily need, some of them aren't going to call out manipulatives at the beginning of the lesson. And that's likely because that lesson was dependent on the idea that 2 or 3 lessons ago you would have done that hands-on. So you just kind of want to think about what do I need to bring in as I'm editing and customizing lessons for my own classroom. But this particular lesson that I pulled started with place value disks. So already we're starting off with the concrete understanding and concrete work in math. So that was great. It was already written in there for me. So they're using place value disks, and then they're modeling 1 more, and they're modeling 10 more, and 1 less and 10 less to start thinking about what they notice as they're manipulating numbers. And then here it jumps into the representational in the form of the arrow method. And actually, I back up. I would say that that's probably more the abstract, the arrow method. So I made a note to myself that if it were my class, I would likely add the number line into this as well. And I just think it's important to have the number line there as a representational model as well. So I would keep the chips, I would add in a number line, and then we could also move from the chips and number line work into using the arrow way or the algorithm. And so that was just one example of how I was kind of thinking about the lesson as I was customizing it. And then the next one is a 5th grade example. So this is the link to the entire document. But this one was kind of all about hands-on concrete mathematics. And so actually there's a note at the beginning of the lesson that warns you, like, this is a long lesson. And the reason for that is because they're doing a lot of paper folding. So you can see up here, it's saying to make sure you have paper and scissors, because they're going to be doing some cutting and folding and manipulating. And so we have over here the example of, here's the paper that represents our pan of brownies or treats or whatever we're taking to school. Up here, it talks about someone taking some brownies to school and having them actually use the paper to draw on, or I like using patty paper and like folding it and having the kids fold it, and it's nice for layering to compare fractions as well. So I do a lot of that in fractions lessons. But that's already, this whole lesson was really built around the idea of being completely hands-on with fractions, which is, fractions are such a hard topic. So the more that we can be really concrete about what fractions are is really helpful. And then again, they're doing a lot of paperwork, and then they move into this representational model of drawing these models. I put a note in here to myself that if this were my lesson, I would likely still have them doing the folding of paper, and then next to it starting to draw the models as we're folding, so that it's not lost on them what those models are that they're drawing. And then they start kind of jumping into abstract ideas. So just an idea of how you could kind of go about thinking about your lesson design, and looking for, is that concrete work in there? And if not, how am I going to add it in there? What about the representational? Or do I want to do that at the same time as the concrete? Or what are we going to do leading into the abstract? But something that we need to kind of think about too is not starting with the abstract. That again, it's really helpful to have kids building their own understandings and connections first, and then drawing on those connections that their brain is making to teach them the abstract versions later. So if you want to practice on your own, I was recently in a chat with a group of math teachers on Twitter. LM Math Chat is a great Thursday night chat for elementary math teachers. And so this was one of our recent chats, was all about CRA, and they posed these problems to us and said, pick one and think about what would CRA look like for these problems. And so my example, I went with the 1st grade sample, and I said, well, my concrete would probably be with some kind of counters or place value blocks or linking cubes likely. Maybe take the linking cubes and have, the girls on the top bunk, and then a different color for the girls on the bottom bunk. And then we could actually physically count the girls on the top and the girls on the bottom, and, maybe even put the linking cubes on top of each other. So a layer on top, a layer on bottom. And that could maybe be our concrete example. And then representational, I kind of went with a bar model, because to me that looked similar to my linking cubes as well. So you can see I kind of put them side by side and then did the same thing here. There were a lot of different examples though that people did, and I'll show you in just a second. And then leading into the abstract. So then teaching them that, oh, all that work that we did, there are symbols that mean that, and that kind of thing. So anyway, if you want to play around with that idea just to get yourself thinking about it, that's something you could do. I'm going to click over here to kind of show you. This was an archive of our chat, but you can see some of the other examples that people came up. Oh, someone posted an example from Engage New York, so you can see again the lesson overview. like I was mentioning earlier, that the lessons build on each other. So as you're customizing your unit for the week or a couple weeks or whatever, just thinking about where the manipulatives coming in. And if you're going to be cutting or changing lessons, to make sure to bring those manipulatives back in and the hands-on work back in. But here are a few other examples. So here's one. It's kind of cute that someone put together. Oh, I missed it. Oh, I just lost it. Oh, here we go. So someone was talking about using 10 frames as their representational model. So that would be really great, and using kind of that spillover method. And some other people had talked about, oh, here was one. So she did something similar. She had the different bars here, and then did not a tape diagram, well, I guess tape diagram or bar model as well, but then also showed like the 10 frames idea too. So just different ways of thinking about that. And again, if you are on Twitter and you want to join this chat, it's a great chat, and we do a lot of great math discussions and practice with each other, and just it's been really, really helpful for me. So that's hashtag LM Math Chat right here on Thursday evenings. So you can email me if you want to join the chat. It's really great. So with that, just a couple of more resources for bringing in visual mathematics as well, which are great for that representational work. And getting kids thinking and talking about math, another really great way to help make math stick. Someone once told me the person doing the talking is the person doing the learning. And I thought, oh, that's got some truth to it, I think. So having kids talking about the hands-on work that they're doing and talking to each other, talking in small groups, talking to the whole class, about their work is great for also helping them build connections. And so here are some links to some other visual math tasks that you might be interested in as well. But that is it for today. So if you have any questions or want to do some like lesson designing work with me, feel free to email or call anytime, and I'm happy to do some of that work with you. So thanks for checking out our mini PD today, and I hope you guys have a great rest of your week.